Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 23 video on the chapter of mensuration, where I will discuss about how to find the circumference and area of a circle, and we will discuss about some application of its area and circumference of a circle. And finally I will solve few example problems. If you have not watched the previous part 22 previous 22 videos, that is part 1 to part 22 on this chapter of mensuration, then I strongly suggest and request that you please watch them also to maintain the continuity of your study on the chapter of mensuration. So this video is part of the playlist CBSE Maths for class 7 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So let's start part 23 video on the topic of circumference and area of a circle. Okay, so I have prepared my quick notes on the left hand side, and on the right hand side I will discuss the concepts and solve the example problems. Okay, so this is about how to find the area and perimeter of a circle. Now we have already studied about circle. What is a circle? The geometry of a circle in your previous class, that is class 6. So what is a circle? A circle is a path where every point on the path is at a constant distance from a fixed point, which is known as the center. So we have a center, and we have the circle is like this. So these are points on the path of the circle, and this is the center. Let's say the center is O. So all these points A, B, C, D, E, all these points F, G are at a constant distance from the point O, and that distance is known as the radius of the circle. So all this distance are is known as the radius of the circle, which is denoted by small r. These are, so OD, OC, OB, OA, and OF and OE are all of same length, and the length is nothing but the radius of the circle. So all these concepts you know. Okay, so the perimeter is not. What is the circumference? The circumference is the path that consists of infinite number of points which are at a fixed distance from the center O, and that distance is known as the radius r. And what is the perimeter of a circle? The circumference of a circle is the perimeter of the circle. So what is the formula and what is the diameter? The diameter of the circle, is that you take any 2 points on the circumference. Let's say I am taking point P. This is a P on the circumference of the circle, and if I draw a straight line, if I connect P and Q, if I draw the line segment, if I draw a line segment passing through the center O, and if that line segment intersects the circumference again at the point Q, then PQ is the diameter. So these concepts you already know. So radius, notation wise, radius is denoted by small r of a circle, and diameter is nothing but twice the radius. Diameter is denoted by small d, is twice r, and the circumference or the perimeter of a circle is nothing but the circumference of the circle. So perimeter P is 2 pi r. This is the formula. Now what is pi? Now it has been it has been from where did this formula came, that perimeter P is equal to 2 into pi into r. Pi is a constant. Pi is a constant whose approximate value is approximately pi is 22 by 7, which is in decimal format 3.14. Okay. Now it has been observed that if you draw circles of various radius, then the ratio circumference of any circle, that is of any circle of any size, you take a circle of any size, that is any radius, then the circumference, the ratio of circumference by and the diameter has been found to be a constant, and this constant is nothing but the pi. Okay. And so from here we get that circumference is also denoted by the capital letter C, is equal to diameter multiplied by pi. Diameter is nothing but twice r multiplied by pi, so this is equal to 2 pi r. So this is in short how the formula came of the perimeter, which is 2 into pi r. Okay, or this is equal to pi d, because twice r is equal to d, so this is equal to pi d. So where d is the diameter of the circle. Okay, now what is the area? Area of a circle of radius r, area is equal to pi r square. Now there is a mathematical explanation why the area of a circle of radius r is pi r square. I will not get into that. I will just discuss about the basic formula and will use them in solving problems. So area of a circle of radius r is pi r square, and the circumference of the perimeter is 2 pi r. These are the main two formulas of a circle, that is its area, which is pi r square, and its perimeter, that is the circumference, which is 2 pi r. 2 pi r, which is also equal to pi d. Now you must be very well aware of all the conversions, like diameter in terms of radius, radius in terms of diameter, perimeter in terms of diameter, perimeter in terms of radius. All these concepts you must be well aware of. I mean, I'm not asking to remember them, but let's say we know that area is pi r square. Suppose we have to find the area in terms of diameter. What will be pi r square in terms of diameter? R we know is d by 2. So this is r is d by 2 square. So this becomes pi d square by 4. So the area of the square in terms of a diameter is pi d square by 4, and the standard area, formula is pi r square, where r is the radius. So these are the two fundamental concept and formula of circumference or perimeter of a circle and the area. Okay, now let's discuss about few other related concepts about circle. The first one is the length of an arc of a circle that makes an angle theta degree at the center. So let's consider a circle. What is an arc? An arc is a part of the circumference. An arc is a part of a circumference which has a starting point and an end point. Let's say I am considering an arc AB. Let's say AB is an arc. So this is an arc. This is an arc. An arc, I guess, is represented. The notation is like this. This means AB is an arc. So it has two endpoints A and B. Now, if you let's say the center of the circle is O. Now, if you join the endpoints of the arc with the center, that is AO and OB, then AO and OB is making an angle. Let's say this angle is theta. Now, this angle is theta. Now, let's say the length of this arc, this part, the part of the circumference, that is the length of the circumference from A to B, let's say this length be L. This is the length of the arc. Now what is the relation between and let's say the radius of this circle is R. So this is R. So we have AO equals to OB is the radius of the circle, and angle AOB, that is the angle which the arc is making at the center of the circle, is theta degree. Then what will be the length L? What will be, how can we find L in terms of theta and R? Okay, now the concept is that if so, as you can see, if theta is 360 degree, if you increase let's say theta, if you think of the values of theta let's say you are starting, let's say the starting value of theta is 0 and you are slowly increasing the theta, so the length arc AB will obviously increase, and at one point of time when you will complete a full circle, that is when theta will be 360 degree, then the arc AB will be the entire circumference. So to find the length L, to find L in terms of R and theta, the concept that I will apply is that we know that we know that for 360 degree, if theta is 60 degree, for 360 degree the length of arc is equal to the circumference, which is 2 pi r, where smaller is the radius of this circle. So if this theta degree was 360 degree, then obviously the arc AB would have spanned the entire circumference of the circle. So in that case, L would have been equal to the circumference of the circle, which is 2 pi r. So now for 1 degree, I am applying the concept of unitary method. So for 1 degree, the length of arc will be equal to 2 pi r divided by 360 degree. So this implies for theta degree, the length of arc will be equal to 2 pi r divided by 360 degree multiplied by theta degree. This is equal to we write it as theta by 360 degree, not degree will cancel out, so theta by 360 multiplied by 2 pi r. So this implies we get the formula that L is equal to theta by 360 multiplied by 2 pi r. So the length of an arc AB, which is making an angle theta at the center of a circle of radius r, if we consider the length to be L, then L will be equal to theta by 360 multiplied by 2 pi r. Okay, so this was the length of an arc that makes an angle theta degree at the center of a circle of radius r. Okay, let's see the next concept. Now, what is a area of a semicircle? Area and perimeter of a semicircle. What is a semicircle? So a semicircle is nothing but half of a circle. So let's say this is a circle of radius r. Now what will be the semicircle of this circle? It will be something like this. My drawing may not be very accurate, but this is the semicircle. That is, if you divide the circle across any diameter, you know that in a circle there are infinite number of diameters, because because since there are infinite number of points on the circumference of a circle, you can join any two point on the circumference which passes through the center, that will be a diameter. And since there are infinite number of points on the circumference of a circle, there are infinite diameters. So if you divide the circle in a two half, then one half is known as is a semicircle. So this is, so let's say, so A, B, and let's say one point C. So ABC is a semicircle. ABC is a semicircle centered at the point O. So definitely in this semicircle ACB, we have AO is equal to OB is equal to R, and obviously AB is the diameter, which is twice R. So ACB is a semicircle of radius R. So this is R. Also this is R. Now what will be the area of this semicircle of radius R and its perimeter? Obviously the area will be half the area of the full circle. For this full circle, we know the area is equal to pi r square. So definitely for the semicircle, the area will be pi r square by 2. But what will be the perimeter of this semicircle, that is ACB? The perimeter of the circle ACB will be, for the full circle we know perimeter is equal to 2 pi r, and for the semicircle the perimeter will be the half of the circumference, that is ACB, this part. This is the half of the circumference, which will be half of the circumference means 2 pi r is the full circumference, half of it means this, plus the diameter, that is the line segment AOB. So the diameter is twice r, which is equal to pi r plus 2r, which is equal to r multiplied by pi plus 2. So r multiplied by pi plus 2 is the perimeter of a semicircle of radius r. And obviously the area of a semicircle of radius r is pi r square by 2. Okay. Now let's see what is a sector. What is a sector of a circle, and how to find the area and the perimeter of a sector of a circle. Okay, so what is a sector? Sector is related to the arc. Let's say I have a circle, this, and let's say there is an arc AB. There is an arc AB, let's say, which is making at the center. Let O be the center of the circle, and this arc is making an angle theta at the center, theta degree. So what is the sector? The sector is the figure. The sector is, let me highlight with a let me highlight the sector by shading it with a color. So this part, it will be so this part is the sector. So this is the sector of a circle of radius r. The circle has a radius r, and the sector is making an angle theta degree at the center. So this shaded region is a sector of the circle. So so what are the parameters that defines a sector? It is nothing but an arc that makes an angle theta degree at the center of the circle and the radius of the circle. So for this shaded region, what will be its area and what will be its perimeter? Now the area will also be the way we will find the area of the shaded region will be same as we found the length of the arc. We know that the concept is same applying the unitary method. If this theta degree, if the theta degree was 360 degree, then this shaded region would have been the entire circle, and we know the area of the entire circle is pi r square. So we know that for 360 degree area of sector, in that case the sector would be the entire circle. Area of sector is equal to pi r square. Now for 1 degree area of sector will be equal to pi r square by 360 degree. So this implies for theta degree area of sector will be equal to pi r square by 360 degree multiplied by theta degree. This is equal to theta by 360 whole multiplied by pi r square. So the area of this shaded region, which is a sector, and the sector is nothing but an arc AB that makes an angle theta degree at the center. So for this the shaded region, the area of the shaded region will be theta by 360 multiplied by pi r square, where where r is the radius of the circle. Okay, now what will be so area of sector, I'm referring AOB as the sector. Area of sector AOB is equal to theta by 360 multiplied by pi r square, where theta is the angle the sector is making at the center of the circle of radius r. Now what will be the perimeter? Perimeter of the shaded region. Perimeter of the shaded region is AO plus OB plus the arc AB Now what is AO? AO and OB is equal to the radius of the circle. So R plus R. And what is the AB? We know that AB is the arc. AB is basically L. And we know earlier we have found the formula for L. That is the length of the arc that makes an angle theta degree at the center of the circle. L was theta by 360. So this is equal to becomes twice R plus L was theta by 360 multiplied by 2 pi R. So this will be the perimeter of the so this is equal to twice R plus, if you simplify, 2 will cancel 360 with 180, so this will be theta by 180 multiplied by pi r. So this is the formula for the perimeter of the shaded region, that is the sector which makes an angle theta degree at the center of the circle of radius r. Okay, so this was about area and perimeter of a sector. The next is the area of a ring. Now what is a ring? A ring is nothing but it has an outer circle and inner circle. So how is a ring formed? So a ring is formed by two circles, where one circle is inside another circle and the ring has a gap. That is, you can consider a ring as there is a bigger circle, the outer circle, let's say, and there is an inner circle. Let's say the inner circle has radius small r and the outer circle has radius capital R, where obviously capital R is greater than small r. So what is the ring here? The ring is this part. The shaded region, I don't know whether I will be able to properly shade the region. I'm trying. Okay, I hope you got the idea. So this is the ring. This will not be. I hope you got the idea. So this is the ring. Now, how do we find the area of the ring? That is the shaded region. Obviously, where is? Okay. So how do we find the area of the shaded region, which is the ring? The area of the shaded region is nothing but, if you consider the outer circle, if you find the area of the outer circle and if you subtract from that the area of the inner circle, it will be the area of the ring. So area of ring is equal to the area of the outer circle, that is the bigger circle, is pi r square, and the area of the inner circle is pi small r square. So this is equal to pi into capital R square minus small r square. So this is the area of the ring or the shaded region. Okay. Now this I have also written down few other concepts like largest circle inscribed in a square, and area of that inscribed circle, and the area of largest circle inscribed in a rectangle, largest circle inscribed in an equilateral triangle. All these concepts I will discuss in some future videos. As of now, I will end the discussion here regarding the concepts and formulas. Now, based on whatever I have discussed, that is starting from the beginning, let's quickly recap what I have discussed so far. We have the basic definition of the area and perimeter of a circle. The area, we know that a circle having radius small r, small r is used to denote the radius of a circle, small d is used to denote the diameter of a circle. So d is equal to twice r, and we have perimeter, p is equal to twice 2 pi r, which is equal to pi d, and area is equal to pi r square, or in terms of diameter it is pi d square by 4. Next we have length of an arc. The length of an arc which makes an angle theta in a circle of radius r, it will be, if the length of the arc is L, it will be, L will be equal to theta by 360 multiplied by 2 pi r. The next was the semicircle. A semicircle is nothing but half of a circle. Half of a circle. So a semicircle of radius r, what will be its area? Its area will be pi r square by 2. What will be its perimeter? Its perimeter will be the half of the circumference, which is pi r, and the diameter. So pi r plus diameter d is equal to twice r. So pi r plus twice r, which is equal to r into pi plus 2. Next was a sector. What is a sector? A sector is the entire region that is created by an arc of a circle of radius r that makes an angle theta degree at the center. So the area of a sector which makes an angle theta degree at the center of a circle r of radius r is theta by 360 multiplied by pi r square, and the perimeter is equal to twice r plus theta by 360 multiplied by 2 pi r. Next was a ring. How do we find the area of a ring? A ring is nothing but is composed of two circles, outer circle and inner circle. If the outer circle has a radius capital R and the inner circle has a capital small r, then the area of the ring is pi into capital R square minus small r square. Okay, so based on these concepts, let's try to solve a few example problems. Now, while I am solving the example problems, always try to solve the problems yourself first, and then pause my video and solve these problems yourself first, and then once you have solved it, you can check your answer with my solution. And also please do watch my solution to get how I am applying the concept to solve these problems. Okay. Question number 1. It says that the area of a circle having circumference C is, okay, so the circumference of a circle is given to be C. What will be the area of the circle based on C in terms of C? Okay. So for to find the area of a circle, we know that we need the radius. We need the radius. So once we have found the radius R in terms of C, we can find the area. So what is circumference of a circle? That is a perimeter. So C will be equal to twice pi R. If we consider R, small r, to be the radius of the circle. So this implies we can easily get the radius of the circle. R is equal to C by twice 2 pi. 2 pi. R is equal to C by 2 pi. So this implies the area is equal to pi R square, which is equal to pi multiplied by C by 2 pi whole square. This is equal to pi C square by 2 pi square. This is equal to pi C square by 4 pi square, and this is equal to pi will cancel out, 1 pi will cancel out, and we have this is equal to C square by 4 pi. So the area of the circle will be C square by 4 pi. So the correct choice is D. D is the correct choice. Let's see the next problem. Question number 2. The area of a semicircle is A, then its perimeter is, okay, the area of a semicircle is A, then its perimeter is. Now to know the perimeter or the area of a semicircle, all we need to know is the radius. The area of a semicircle is given to be A. So we know that if we consider small r as the radius of the semicircle, its area will be, we know that area will be equal to pi r square by 2. If r is the radius of a semicircle, then its area is pi r square by 2, which is given to be A. So from here we can say we can find r square. So we will have r square is equal to twice A by pi. And this implies r is equal to square root of twice A by pi. So this is r in terms of A. Now we have to find its perimeter. Now what is the perimeter of a semicircle? A perimeter of a semicircle is, so we know that a semicircle is like this. So the perimeter is this part is half of the circumference plus the diameter. So the diameter is twice r, so it will be twice r plus half of the circumference is pi r, because the full circumference is 2 pi r, so half of the circumference will be pi r, which is basically r multiplied by pi plus 2. We know r, so r we know is to be square root of twice A by pi multiplied by, we have pi plus 2. So this is the perimeter of the semicircle having area A. Now remember that the capital A is given to be the area of the semicircle, not the circle. The area of the semicircle of radius r is pi r square by 2. Okay, so this must be the perimeter, and is this matching with any choice? Choice A no, choice B no, choice C is pi plus 2 square root of twice A divided by square root of pi. Okay, now square root of 2A by pi can be rewritten as square root of 2A divided by square root of pi, and this is pi plus 2. So the correct choice is, remember the choice D, it is pi plus 1, but it should be pi plus 2. So the correct choice is C. C is the correct choice. Okay, let's do problem number 3. An arc of length capital L of a circle with diameter small d makes an angle of 45 degree at the center. Then which of the following is correct? Okay, so there is an arc. The length of the arc is given to be capital L, and the arc is of a circle with diameter d. That is, its radius will be d by 2. Okay, so what is the scenario? The scenario is we have a circle. Since with the diameter d, okay, so let's say this is the center of the circle O, and so this is d. So if diameter is d, then definitely the radius will be d by 2. So let's say this is the radius r. This is the radius r. Okay, so there is an arc of length capital L with diameter d of a circle with diameter d, which makes an angle 45 degree at the center. Okay, so let's say this is the arc A, B is the arc, and this is 45 degree, and this length is given to be capital L. So we know that what is the relation between, what is the formula that relates the length of the arc, the degree, the angle it makes at the center of the circle, and the radius of the circle. We know that L is equal to theta by 360 whole multiplied by 2 pi r. This is the formula that connects the length of an arc small l, which makes an angle theta degree at the center of a circle, and the circle is having a radius small r. So in this formula, if we put the given values in this problem, we are given the length of the arc is capital L. So we have capital L is equal to theta is 45 degree. So we have 45 by 360 multiplied by we must have 2 pi r. Now 2 pi r is also equal to pi d, because twice r is equal to d. So and d is the diameter of the circle. So and in the problem the diameter is given to be d. So we can say 2 pi r will be equal to pi d. Okay. So this is equal to 45 divided by 360 is 1 by 8. So this is pi d by 8. Pi d by 8. Okay. So we have L is equal to, capital L is equal to pi d by 8. So the correct choice is B. B is the correct choice. Let's see question number 4. A wire in the shape a wire in the shape of a square is ribboned into a circle. Then the ratio of area of square to the area of circle is. A wire in the shape of a square is ribboned into a circle. So no dimension is given. The side of the square is not given. The perimeter of the square is not given. Nothing is given. It is just given that a wire, whatever, whatever you can consider any length of the wire. So a wire initially in the shape of a square is ribboned into a circle, which means that whenever in this kind of problem, when you are given that a wire is in the shape of a figure, let's say figure 1, and it is ribboned into a figure 2, then obviously the perimeter of figure 1 should be equal to the perimeter of the figure 2, because the length of the wire is constant. It will not change. Okay, so let's try to visualize what is happening. So we have a square. Let's say when the wire was in the shape of a square, the length of each side of the square was x. Okay, so the length of the wire, let's say if it is capital L, then will be 4x, because the perimeter of the square is 4x. We are assuming that when the wire was in the shape of a square, the length of each side of the square is x, then the length of the wire will be 4x. Now it has been ribboned into a circle. Let's say this circle has a radius of small r. Now, so we must also have capital L, because the length of the wire is fixed. Capital L should be equal to the circumference or the perimeter of the circle, which is 2 pi r. Okay. Now the question has asked, then the ratio of area of square to the area of circle is. Okay. So now if we consider, let's try to think this problem in a different way. Let's say the length of the wire, it is fixed. The length of the wire is not changing. Let's say the length of the wire is L, capital L. Then we must have capital L is equal to 4x. From here, where x is the diameter, x is the length of each side of the square. From here we will get x should be equal to L by 4. L by 4. Okay. And when the wire has been ribboned into a circle, we must have capital L is equal to 2 pi r. So this implies small r should be equal to L by 2 pi. Okay. Now what will be the area of the circle? The area of the square. Area of the square is x square, which is equal to L by 4 square, which is equal to L square by 16. And what will be the area of the circle? Area of the circle is pi r square. It is pi r square. This is equal to pi. What is r? R is L by 2 pi square. This is equal to pi L square by 4 pi square. This after simplification is L square by 4 pi. So the area of the square is L square by 16, and the area of the circle is L square by 4 pi, where we have assumed the length of the wire to be capital L. So let's say the area of the square be A1 and the area of the circle be A2. So this implies we have to find the ratio of the area of square to the area of the circle. So A1 by A2 is equal to L square by 16 divided by L square by 4 pi. This after simplification becomes L square. Okay, so this is equal to L square by 16 multiplied by 4 pi by L square. This is equal to L square cancels out. This is equal to pi by 4. Pi by 4. Okay, so this implies A1 is to A2 is equal to pi is to 4. So the ratio of the area of the square to the area of the circle is pi is to 4. Pi is to 4. So the correct choice is B. B is the correct choice. Okay, let's do the next problem. Question number 5. Okay, so there is a figure. BC is an arc. BC is an arc of a circle of radius capital R. Okay, making an angle theta at the center O. AD is an arc of a circle of radius small r, making angle theta, that is the same angle theta at the center O. That is, we are having BO is equal to OC is equal to capital R, and AO is equal to OD is equal to small r. Then what is the perimeter of the shaded figure ABCD? We have to find the perimeter of the shaded region. Okay, so what is happening? We have we have a bigger circle, we have a bigger arc BC, which is making an angle theta at the center of a circle with radius capital R. So okay, so let's try to visualize this figure with a circle. So we have the bigger circle. Let's say this is this circle. Let's say the arc BC, the arc. So this is the arc BC, which is making an angle theta with the center of the circle of radius capital R. Okay, so this is theta. There is another arc AD which is also making an angle theta. So AD is an arc of another circle of smaller radius, which is small r, which is also making an angle theta at the center O. So O is the common center for both the bigger circle and the smaller circle. So let's say if I consider this to be let's say something like this. This is the smaller circle. So this is A at this point. This point is A, and this point is D. And so this arc AD is also making an angle theta at the common center. Let the common center be O, and this part is small r. This part is small r. Okay. So we have to find the perimeter of the shaded figure. Now, what is the perimeter of the shaded figure? Perimeter of shaded region or figure is equal to we have this AB plus the arc of BC, which is an arc, plus DC plus the arc AD. This is the entire so AB plus the arc BC plus DC. Now AB and DC are line segments. AB and DC are line segments, and BC and AD are arc. Okay. Now what is AB? What is AB? AB is nothing but OB minus OA, and we have arc DC plus what is DC? DC is nothing but OC minus OD, and we have plus the arc AD. Okay. Perimeter of shaded region, let the perimeter of the shaded region be denoted with the capital P. Now let's find out what is a BC. Length of arc, let's consider. Now this thing refers to the arc BC. This actually does not mean the length of the arc BC. So let's say I should have written let's say length of the arc BC is equal to L1, and length of arc AD be L2. Then I should write perimeter of shaded region should be equal to AB plus arc the length of arc BC, which is L1, and DC plus the length of the arc AD, which is L2. Okay. So this will be L1 and this will be L2. Now we have to find what is L1 and L2 from the formula. We know that L1 is nothing but the arc BC is nothing but it is an arc that is making an angle theta of a circle of radius capital R. So L1 will be theta by 360 multiplied by 2 pi capital R. Similarly, L2 is nothing but the length of the arc AD, which is formed on a circle of radius small r, and the arc is making an angle theta at the center of the circle. So L2 will be theta by 360 multiplied by 2 pi small r. So now what is so therefore now so what is so P also what is OB over what is OB minus OA? What is OB minus OA? What is OB? OB is nothing but the radius of the bigger circle, that is capital R. And what is OA? OA is the radius of the smaller circle, that is small r. So OB minus OA is R minus capital R minus small r. And what is OC minus OD? OC minus OD is also, OC is also capital R and OD is also small r. Okay. So we have now perimeter equals to OB minus OA is equal to capital R minus small r plus we have OC minus OD is also capital R minus small r, and then we have L1. L1 is theta by 360 multiplied by 2 pi capital R, and we have plus L2 which is theta by 360 multiplied by 2 pi small r. If you simplify this, we have 2 times capital R minus small r, so we have 2 capital R minus small r plus from these two terms I can take common 2 pi theta by 360. So 2 pi theta by 360, if I take common, I will have capital R plus small r. This should be the perimeter of the shaded region. Twice of capital R minus R is only there in the option B, but in the option B we are having plus pi theta by 180. Okay, so this is equal to twice of capital R minus small r plus 2 pi theta by 360. 2 will cancel 360 by 180, so this will be pi theta by 180 multiplied by R, capital R plus small r. So the correct choice is B. B is the correct choice. Okay, let's do the last problem, question number 6. A circular plot of radius R has a road of uniform width M running outside along the plot. So there is a circular plot. This has the radius capital R, and there is has a road of this circular plot has a road of uniform width M running outside along the plot. That means the path will be also circular, which is outside this circular plot of radius capital R, but and of uniform width small m. So this circle should be the road will be like this, and this, and so this is capital R. So this, all these widths is uniform, which is small m. So this must also be small m. So now what will be, so we can see we have a ring, the circular plot and the road is forming a ring. So basically we can now say the area of the road is nothing but it's a kind of ring. We have to find the area of the ring. Now in this ring, what is the what is the radius of the outer circle? So radius of outer circle will be equal to the radius of the circular plot, which is capital R, plus the uniform width of the road, which is small m. So this is the radius of the outer circle, and of course the radius of inner circle is nothing but is equal to the radius of the circular plot, which is capital R. Now the question is asked, what is the cost of making the road at the rate of rupees X per square unit? So first we need to find the area of the road, which is nothing but the area of the ring, where in the ring the radius of the outer circle is R, capital R, plus m, small m, where small m is given to be the uniform width of the road, and the radius of the inner circle is the radius of the circular plot, which is capital R. So we know that the area of the ring or the area of a road will be equal to now pi. The formula was, we know, pi into R square, capital R square, minus small r square, where capital R is the area of the outer ring and small r is the area of the inner ring, or R1 is the area of the outer ring and R2 is the area of inner ring, radius of inner ring. So area of the road will obviously be pi capital R plus small m square minus R square. So this is equal to pi. If you expand R plus m whole square using the algebraic identity a plus b whole square as a square plus twice ab plus b square, this becomes capital R square plus small r square plus m square plus twice r m, and we have minus r square. So this is equal to pi, r square cancels out, and we have m square plus twice r m. If I take out m as common, this is pi m plus twice r. So this is the area of the road, that is pi m into m plus twice r. So this implies cost of making the road will be equal to the area of the road multiplied by the rate of making the road. So this will be obviously equal to rupees, the rate is x. The rate of making the road is given to be x, rupees x per square unit, and the area of the road is pi m into m plus twice r, this much. Actually this should be square units. Okay, so now the cost of making the road will be area multiplied by the rate per square unit, and the area is pi m multiplied by m plus twice r. This is the area, and the rate was x. So this is equal to what is the cost of making the road at the rate of rupees x per square unit. So this must be I think there is a mistake in the choice. The cost will be rupees pi mx multiplied by m plus twice r. X is missing in all the choices, so this should be the answer, rupees pi mx multiplied by m plus twice r. So I think the nearest choice that matches with my answer is, even though x is not there in any of the choices, the correct choice should be m plus twice r. So the choice should be C, but x is missing. So it's my mistake. I have forgot to give the x. in all the choices. Anyway, so this is the cost. So with this, it comes to an end in the discussion of area and perimeter of a circle and its related concept, and solving 6 problems that will give you a good practice of your understanding of the concept of area and perimeter of a circle. In the next video, I will solve the problems of exercise. I will solve the problems of exercise 20F, which are based on area and perimeter of circle. So after solving the problems of exercise 20F, I will solve the objective questions, which is exercise 20G. This exercise consists of concepts of from the entire chapter of mensuration, that is area of a square, rectangle, parallelogram, rhombus, triangle and circle. And finally, there are many questions in in exercise 20G. There are about 32 questions. Obviously, I will solve them in multiple videos. And finally, there is the test paper 20. So these videos are coming soon, so please stay tuned. If this video was beneficial, please like it, share it with your friends, and once again, please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. I will end the video here. Thanks for watching, and until the next video, take care and bye.